Hello guys, welcome back to another video. Welcome back to another video hosted on the Prep Master channel. So what we're going to be looking at today is how to find the square root of any number. This is done using the rounding down principle. Okay, let's move on then. So before we move on, I just want to say that we'll be solving questions. We'll be having questions. We'll be having quick tests, which will jumpstart you. So after this, we're going to have a very quick test, which is going to jumpstart you into understanding a bit of what we're looking into here. This new method of finding the square root of any number. So let's move on. So a quick meal to get you started. Without using your calculator, what is the root of 36? You have 3 seconds. 3, 2, 1. If you get 6, you're correct. So, okay, since you got that one, root of 36 is equal to 6. Okay, let's move to the next one. Another quick meal. What, without using your calculator, what is the root of 39? You have 3 seconds. 3, 2, 1. Well, if you get 6.4499979983983205, you are absolutely a genius. Well, you now ask yourself, how am I going to know all these numbers? These are too many numbers. Well, let me tell you, this method does not require you to know any of these numbers you see in your screen. It only requires you to know the first digit before the decimal point. So let's move on. Let us analyze this more better. So the things you must know before you can understand this method of finding the root of any number, you must first know at least all perfect squares from 1 to 100 and their square roots also. So what are perfect squares, you might ask? Well, perfect squares are set of numbers that you can find the square root of them without getting a remainder. Now, going back to that first question we had what is the root of 36? Now, 36 is a perfect square, so therefore it should not give us any remainder. Correct. So we only have 6 or 6.0 or 6.000. As far as the decimal point is 0, 0, absolutely nothing, to the extent where you can just remove it out. Well, it is a perfect square. But in a case like this, where they say what is root 39 and it's giving you remainders, decimal portions of the number, like instead of it just giving you directly 6, it's giving you these decimals. So therefore, it's not a perfect square. So I'll say the definition of perfect square again. A perfect square is a number or a set of numbers that in which you can find the square roots of them without a remainder. If you check, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. You see, they're not giving us any remainder. We're not giving us like 4.222 or 3.222. It's just giving us directly 4, directly 3, directly 2, and directly 1. So moving on, you must also know how to round down a number. As I said in the beginning, we'll be using the principle of rounding down numbers. So how do you round down a number? For instance, we have a number like 5.9. To round down a number is basically the opposite of rounding up a number. If we were to round up this 5.9, we'll get 6.0. So from the basic law of rounding up, if the number beside the number you're trying to the starting position, which is we're trying to round it up, so we're trying to remove the decimal portion. So we'll start from the first one. So if we're trying to round it up, we'll basically consider 9. Then okay, we're trying to round it up, sorry. So we're going to look at 5. So we'll look at the number after 5. If it's is it greater than 5? Yes, it's greater than 5. So we'll add 1 to the number before it. So that will now turn into 6.0. So therefore we have rounded it up. But in this case, we're talking about rounding down numbers. So basically the way to round that number is just remove the decimal portion of the number, simple and short. So from 5.9 to 5, from 12.345 to 12. That's basically how to round that number. Just remove the decimal portion of the number. So moving on, we have this chart here showing us the perfect squares from 1 to 100. As you can see, they are all on the diagonal part of the chart. And if we count them, we have 2, 4, 6, 8, 10. So therefore, there are 10 perfect squares from 1 to 100. You just need to memorize them, know the square root of them, That's what you just need to know. Once you know that, you'll be able to use this method that I'm about to show you right now. So let us now go into this method now and know how to use this method to find the square root of any number. Okay, we have our first question here, which says, what is the root of 39? So let us analyze the solution step by step. So step 1. First, what is the closest perfect square to 39 that is below it? So let us check our charts. So these are the list of perfect squares from 1 down to 100 in this yellow portion of this table. So where can we find 39 in this range that we are seeing here, this range here? So we can see that 39 is in between 36 and 34. Well, what step 1 says is find the closest perfect square that is below it. So the closest perfect square that is below 39 is therefore 36. So now that's how we got this 36 here. So that is 36. Step 1, we're done with step 1. So step 2, what is now the root of that 36? Well, we already know that the square root of 36 is 6. Step 2, we're done. Step 3, hence the root of 39 is 6 point something something something. Why is this so? Why is this so? Why is it that the root of 36 is 6 point something something something? So first of all, let us go back to the graph. What is the root of 36? 6, right? Root of 36 is 6. Root of 49 is 7. And we know that in between these two perfect squares, there are other numbers from 37 down to 48. So therefore, we can also say that the square root of those numbers are within this range, meaning that for the root of 37, we can probably have 6.1 as the root of 37. Then the root of 38, we can probably have 6.1 something or 6.2 or within that range. So it is sure within the range of 6 to 7. So it can never be 6, it can never be 7. So root of 37 can never be 6, directly 6, 6.0, what I'm trying to say, directly 6 can never be directly 6. Same as root of 48 can never be directly 7, because it's only the root of 49 that is 7. Only the root of 49 that is 7. There's no other number that you can find the square root of it that will give you 47. So same goes to 36. There's no other number within the range that will give you exactly 6 apart from 36. So therefore, we have already proved that the square root of 39 is therefore 6 point something something something. Furthermore, we can also say that from this observation now, we can also say that the root of 39, the square root of 39 can be found within the range within 6 to 6.999. Why is it 6.999 instead of 7? Because the range, because it can never be 7 and it can never be 6. So this is a mistake. This should be 6.1. 6.1. Yes, this should be 6.1 or 6.0001 or 6.00. So I just put 6 there to avoid the infinity part of the decimal portion. So yes. So we also note too that this method is only true and it only works for finding the square roots of numbers that are not perfect squares, meaning that this formula for finding the root of this number of this formula, finding the root of any number that is not a perfect square only works for only numbers that are not perfect square. We cannot use it to find there will be no point of using it to find using this method to find the root of a perfect square, because we already know that the root of 36 is 6. We already know that the root of 49 is 7. We already know that the root of 64 is 4. So why do we now need a new method for that? It doesn't matter. We already know that through our normal mentality, through our everyday mathematics. So let's move to question 2 using the same steps, using the same analysis. So step 1, we're asked what is the square root of 63. Step 1, what is the closest perfect square to 36 that is below it? Going to our chart again. Where can we find 36 within this line we drew here? We can see that's in between 49 and it's in between 64. Okay, let me just state something before we move on. We can also see that 36 is very, very close to 34. So after 36, what do we have? 60. Sorry, we can see that 63 is very, very close to 64. So after 64, we have 6. So after 36, we have 64. So that's the observation I just wanted to state out there, that 63 is very, very close to 64. I'll show you why we need this observation. So let us continue. So the closest perfect square to 63 that is below it is 49. We're talking about, when I say below it, I basically mean the numbers that are before 63. The closest perfect square before 63 is 49. So step 2, what is now the root of that 49? We already know that root of 49 is 7 from our basic everyday mathematics. Uh, so step 3 now, hence the square root of 36 is therefore 7 point something something something. So now let us use that observation we had before. We saw that 63 is more closer to, so after 63, what do we have? 64, right? And from that our observation before, we said that the range, so we can also see that the range of, so what is now the range of this? We can see that furthermore, we can also say that the root of 36, the root of 63 can be found within the range of 77.9. So we can see that since it is more closer, since the difference between 64 and 63 is 1, meaning that it's just 63 is just one step behind 64, we can therefore say that it is the root of this 37, this 63 is therefore 7.1 something something something, 7.9 something something something. Why? Because as I said before, the range is 7 to 7.9. We can therefore say that the numbers within the square root of the perfect square is between 49 to this perfect square. So let's check our graph. This perfect square, the numbers within the perfect square 49 and the other perfect square 64 are therefore, as they are increasing, just so as the square root of the number is also increasing. What does this mean? Let's go back to the graph. So this means that for 50, we should have 50.1 something something. So when we find the square root of 50, we should have 7.1 something something something. Same as 52, we should have either 51, either we should have the, so if you find the square root of 52, we should have something like 7.2 or 7.1, depending, it depends, it's somehow. But we know that the square root of 50 it should definitely be 51.1, because that decimal point has to be added. So that 0.1 has to be added to the first number after that perfect square. And also, same goes to the number at the last before the next perfect square, meaning that 63 definitely has to be 0.1 behind uh, the square root of the next perfect square, meaning that 63 should be 7.9. So that's how we got this 7.9. So it should be 0.1 step behind the square root of 64, which is 8. So therefore, 8 minus 0.1 should be 7.9. So that's how we got the perfect square, the root of 63 to be 7.9 something something something. So you don't need to memorize this other decimal point. Now you might ask, where do we now need to now apply this formula? So imagine in option A, you were given option A for a number, for this number 63. That is to find the root of, maybe you solve in your CBT, you just quickly solve and you ended up with root of 63, and you're trying to find that before you can now pick your answer. And they now give you option A as 7.1, option B as 8 point, sorry, 8.3, and option C as 8 points, let's say 7 points. They give you option C as 7.9 and option D as, let's say, 7.2. So now, which one will you pick? We know that the square root of 63 from our first method, we just know that square root of 63 is okay. Square root of 49 7. Okay, it should be 7.7 something. But now we're having different versions of 7 here. We're having 7.1, we're having 7.9. So we already know from our this method that the answer can never be 8.3. So I've cancelled option B out. So now we're not left with this one. So now how do we now know which one is now correct? So now from this next observation, from that observation now, you can see that 63 is closer to 64. So therefore, the answer should be more closer to the square root of 64 rather than the square root of 49. What does this mean? It should be more closer to the square root of 64 rather than, sorry, it should be more closer to the right hand side rather than the left. Why? Because, sorry, 64, it should be the number, the square root of it, the square root of this 63, you see, is more closer here because after 63 we have 64. So we know that the square root of 49 is 7, and we then have some other numbers, 7.1, 7.2, 7.3. Then from there we now have that then we then have 8 next. So after all these 7.1, 7.2, 7.3, down to those decimal down to 8. So since 63 is more closer to 64, so as the answer for root 63 should therefore be closer to 8. Which of these numbers now are now closer to 8? That is option C. And that's how you just pick your answer and you move forward. So let us move to another example. This time we have what is root 120. Using our step 1, we will get 100. So the closest perfect square that is below 120 is 100. Step 2, what is the root of 100? We know that as 10. Hence, the root of 120 is 10 point something something something. And if you use that observation, we can therefore say that, okay, what's the closest perfect square? What's the next perfect square after 10? That should be 11 squared, right? That should be 121. So you can see that 120 is more closer to 121. So therefore, we have 10 on the right, and we have, sorry, we have 11 on the right, and we have 10 on the right. So therefore, the root of 120 should therefore be more closer to 11 because it's more closer to the perfect square of 11 rather than the perfect square of 10. Assuming this number was maybe 90, maybe assuming this number was like 101, let's say they've told you to find the square root of 101, we can then say that the answer for this should be closer to 10 because 101 is closer to 100. So the number should be closer to 10. So if they give you 10.1, you just pick it. If other numbers are 10.7, 10.8, 10.9, the other options are more closer to 11 rather than 10. So you just pick the one that is more closer to 10. Since 101 is more closer to 100, so you pick the answer that is more closer to 10, which is the square root of 100. So that is what this observation is basically trying to infer here. Let us go to another example. And this is the final example before we call it a day. So what is root 145? So root 145, using our step 1, what is the closest perfect square to 145 that's below it? We already know that as 144. So just from this way, like just from knowing step 1, I cannot ask you what if what is now the square root of this number? Should it be 12.1? Should it be 12.1? Please bear with me. 12.1 or 12.7? This is decimal place, or 12.9. Now, just by knowing that it is more closer to 12, should it be 12.1, 12.7, or 12.9? Therefore, it should be 12.1 because it is more closer to the perfect square of 12. So it should be more closer. So our answer should be more closer to 12. If the number is more closer to a perfect square, it should be more closer to the square root of that perfect square. Simple and short. So hence our answer is 12 point something something something. From this observation, you can see that it's 12.1 something something something. Since it's just one number ahead of 144, so you cannot say 12.1 something something something. So furthermore, we can also say that 144 can be found within the range of 12 to 12.999. So also the summary of what we've just done today. To be able to find the square root of any number, you must first know the closest perfect square to that number, at least, and you must also know at least all perfect squares from 1 to 100 or 1 to 1000. I'll advise you to know the perfect square of 1 to 1000. It will help you a lot because we also have perfect squares like 625, uh, other perfect squares like 269. That should be the square of I think 20, I think 13. But you must know the perfect squares from 1 to 100. They're not much. It should not be up to 30 or 40 or 50. Within the range of 50. But they're not much. You just need to know them. If you can cram them, fine. If you cannot cram them, fine. Just shall know those important numbers like 625, which is the square of 25. Uh, like something like 121, which is the square of 11. We've already done that before. um which other one, like 900, which is the square of 30. Just know them. These perfect squares from 1 to 1000. They're very simple, not very hard to cram. You don't need to know. You just need to know is, I think, all you just need to know is within the range of, yes, 1 to 30. All you just need to know is the square of all the numbers from 1 to 30. Very small, very little. So they're not much like that. The next thing we also did was that you must know how to round down numbers. So we learned how to round down numbers. So from 5.9 to 5, from 12.345 to 2. Just remove the decimal portion of the number. That is how to round down the number. And we also one thing we also discovered is that this method is only true and it only works for finding the root of numbers that are not perfect squares. For instance, since we already know the square root of 625 is 25, what was not the point of us using a method to find that? It's pointless. So the aim and advantage of knowing this method is that it saves you more time when dealing with multiple choice questions, especially in JAMB or any other CBT, like WAEC now of 2026 is CBT. So if you know how to use this method and you practice it constantly, definitely if you see the root of any number, it will be a breeze for you to choose the answer. So thank you for watching. Prep Master appreciates you. If you found this helpful, please don't forget to like, subscribe, follow for more tips and tricks just like this. Also share with your friends and family who you know who might need it, because you can never tell who it could help. So Prep Master is always here for you. Click that subscribe button, click the notification channel to get updates on our latest videos. Thank you once again. Thank you for your time. Thank you for watching.